First, I'd like to introduce myself. My name's Lila Sferlaza. I'm an associate with Pickard Chilton, and I'd like to thank first everyone who made this event possible: Omar, Mick, Sanjeev, Andy Brayman, Boston Valley, of course, and the University of Buffalo, and everyone who made this event possible. We're very fortunate and honored to be able to take part in this event. So our team is comprised of Pickard Chilton and MKA, who we have with us here today. It took many hands to kind of make our project happen. Here with me on the stage, I have Andrew Barnett with Pickard Chilton, Russell Larson with MKA, and we're also joined by Woo Hyun Lee and Yu Hao Woo, who helped assemble our mock-up. So going into our proposal, what we really wanted to do was, we kind of left our proposal open-ended intentionally in the beginning, but our main goals kind of stuck through the entire process. We really wanted to investigate all of the technical and artistic properties of terracotta, such as texture, color, glaze, but also really fully utilize the material by using it as a strength, using its strength and load-bearing properties. And our ultimate goal was to create sort of a freestanding hybrid structural system, which you could see results in a stair. But I'll hand it over to Andrew to kind of go through that process of how we got to that point.
As we started initially, as Lila mentioned, we kept it very open-ended. We wanted to kind of take a thorough exploration of the kind of history of terracotta usage architecturally, and how we might kind of reinvent some of those techniques and methods and reinterpret them for the 21st century and the capabilities that Boston Valley has as an organization as well. One of the kind of early precedents that we were looking at is not architectural by any means, but Marcel Duchamp's nude descending a staircase. One of the things that really impressed us, and we saw a lot of parallels to with terracotta and its history and expressiveness, was the dynamism that it can add to an otherwise static object, and thinking about how we can carry that through into our process as well. Another precedent that we looked at is one that's definitely more directly related to terracotta and its usage, and it's been excellent to see Louis Sullivan's connection to Art Nouveau as a precedent in Buffalo as well. Some of the work of Victor Horta and the way that he can, again, add dynamism to otherwise very static materials in metal, stone, concrete, terracotta, tile, and then really kind of influence the way that you're experiencing the space and experiencing otherwise commonplace objects and architectural components in that way. Another precedent that we drew from was our collaboration with Magnusson Klemencic. This is a project that they had completed at Burning Man. It is stone blocks that are supported through tensioning rods and is kind of a broken arch with an opening at the top. And was kind of really the fundamental driver for our structural approach, which we'll touch on a little bit more later. One final kind of jumping off point for us was twofold. One, looking back to the historical precedent of flat arches being used as kind of a foundation for floor slabs, and all the benefits that brought in many different ways, although something that has kind of been forgotten or left behind in the building industry. And then also looking at the 2021 presentation at ACAW, a collaboration of Boston Valley, HOK, Perma-Solisa, and Tri-Pyramid with their structural terracotta mullion. We were really intrigued in terms of how this group was able to take a material that can sometimes wrongly be associated with kind of ornamentation, decoration, and really kind of reassert its prominence as a structural material. From this point, we kind of moved into the direction that we were ultimately pursuing, and that was a stair. Drawing on kind of a lot of the fundamental principles that we were able to define in our group exploration, we settled on a twofold kind of reference point for our group in terms of pursuing our design. The first is Gustavino tile, and specifically a staircase that's very familiar to some of our colleagues in this organization at Baker Hall at Carnegie Mellon. And the second is kind of more an inspiration in terms of what this could be. The stair at the Maison de Verre by Pierre Chareau, and how the lightness of that stair can be captured, and how the material innovation and exploration that was kind of prominent at that time really drove all of that. From this point, we continued to push our development using some fundamental goals for ourselves. The first was to use and maximize terracotta and its structural properties, both from a kind of sustainability perspective, and then also because of the kind of onus of this competition or project. The second was to eliminate the visual bulkiness. It's easy to kind of stack up blocks and build just something that you can step over, but to us that was not a true terracotta stair. The third was to explore glazes and textures. The fourth, to design for practical use, to make a stair that you could install into a building tomorrow with proper testing and everything that comes with that. And the last was to take inspiration from nature, as many of the great kind of utilizers of terracotta have in the past. We took a kind of compendium approach to looking at the different ways that we might structurally support a terracotta stair. On the screen are just a few of our approaches on the early end, but it ultimately kind of morphed into a different direction as inspired by the collaboration with MKA. And then some of our early thought processes as we were approaching them. From the far left is a structural stringer with a guardrail and a supported tread, so kind of putting all of the structure in the stringer and the continuous guardrail at the edge and then supporting the tread. The next is drawing from kind of the simple motion of stacking, but kind of pulling away material as you gradually move up, and kind of allowing pressure fit and tension to pull those pieces together. And then the last on the far right is somewhat similar in some ways to our final design, but kind of using fasteners to structurally stiffen and pull together the different terracotta pieces. These are some precedent models. Modeling is a very important component of our studio's practice and was very important in our process here as well. One of the watershed moments for us was kind of taking a step back from some of what we deemed as innovation in our process and going back to the historical successes of terracotta and some of the ways that it had been utilized previously. This one kind of drawing from Gustavino and some of the naturally structural benefits of terracotta as a material and masonry. From this point, kind of looking at this arch, we kind of carried on with this idea and kind of taking the arch and splitting it in half. Obviously, it's a bit more cumbersome architecturally to employ kind of both sides of this arch stair. So by taking one half and moving forward with it, it was able to be a little bit more of a practical application. On the screen here is an early kind of design of that approach with two stringers and then the treads kind of slotted into that stringer. We looked a little bit further into what that stringer makeup might be. On the left is a simply extruded stringer, again kind of drawing from some of the geometries of nature and pulling away from more hardline stringers you might see in precast or preform concrete. On the right, looking at how we might support it with either grouting fully and adding rebar, or on the next slide, looking at how we might use post-tensioning to kind of pull together the stair and allow the terracotta to perform in the way that it functions best. The next component that we looked at was the tread and how that might slot in, ultimately kind of landing with a single stringer and treads that are kind of met by the stringer itself. And this is kind of an early rendering of our fully formed stair with a single tread, a single stringer, and treads resting upon it, and some study models for that. One of the things that made this absolutely possible was our collaboration with the structural engineers at MK, and I think Russell Larson can give a little bit of an overview of that approach as well.
Thank you, and thank you for having me. So let me just give you the real brief snippet of how the math works out for the stair. One thing I should point out is that although the stair is at 3/4 scale, you could scale it up to full scale. This would be code compliant. So this isn't just a piece that's beautiful and here for inspiration, but you could do this. So the question is, how did we do it? Well, terracotta has some advantages over a great many other materials. First of all, it can take impressively more tension. and quite a lot of compression relative to concrete, which is, at least from my perspective, probably its next most akin material. So as you can see here, we got kind of the relative strengths between concrete, steel, and terracotta, and concrete's feeling a little bit alone down there. If you could make, well, as you can see, you've made things here. We've basically drawn on the strengths of compression and that terracotta has, and then utilized steel in probably its most efficient method that it can be, and that is tension. And when we wanted to have a very thin spine down the middle of this, using these materials to their relative strengths is immediately what came to mind. So if we didn't have reinforcing of this, you might expect, well, you probably all would understand what would happen. The thing would kind of sag downwards. And the physics behind that is what happens is that because this is made in, I guess, 6 segments there, the segments would try to kind of pull away from one another at the bottom, and it would sag down and it would scare people, and you know, it would be ungood. And so we want it to be good, not ungood. And so, as with most things, well, if there's a problem, like, fight against it. And so what the post-tensioning does, which is that rod right there, is we used a hydraulic jack to put 10,000 pounds of force pulling together like a clamp the 6 pieces of terracotta. And what that does, if you looked at the little arrows down there, on the previous slide you would have seen some tension happening at the bottom of the terracotta pieces. But this pre-compression clamps it together so that the spine is always in compression. It's always touching one another. And although there's some epoxy and rubber gaskets in there, those aren't really there for structural purposes. Those are there just to, I guess I'll say, even out the very small, but nevertheless a little bit, very small lumps, I guess I'll call it, a technical term. Because this being, you know, I guess a first experimentation with this, we don't want to, you know, crush it and have something crack, and, you know, knock on wood, it did just fine. And so by basically clamping the thing together with strength, we've made use of the abilities of terracotta in what it's best at, and we're able to come up with a very thin structure. And again, you could scale this up, a little bit more force, a little bit more backbone in there, but the math works for this. So I guess we'll go back to the architectural descriptions.
So thinking about the function of the stair, we started to delve into this precedent of using a spinal column, specifically a whale spine, to take hints at its function and as well as how it looks and how it performs. And so we can kind of break down the elements of the stair into anatomical elements. You could think of the tread as sort of the wings of the vertebrae, or the transverse process. You can think of the spine as the stringer that kind of holds everything together. You could see kind of in this detail here on the right, we had aspirations and designs for this sort of rib cage or handrail that could start to provide some structure as well as create something beautiful and usable. So all of these elements together, you could see here in our renderings, this is kind of what we were aspiring towards. This is more of a full-size or full-scale version, but then starting to kind of scale that down into the mock-up, we had to do some scale 2D operations and make sure everything worked, but the intent, I think, is still there, and you could see in these images some initial explorations at texture. And going into kind of texture and glaze, what we really wanted to do was create something bold while celebrating kind of the traditional ceramic qualities, such as pooling, breaking of the glaze, incorporating color in a modern and vibrant way, as well as creating something very functional for the stair. So 3 precedents we were looking at. One was derived from the whale inspiration, scrimshaw, which was the practice of carving into whalebone and inlaying ink. as well as sgraffito, and starting to look at some skeletal microstructures and cellular structures for ideas for the texture. So you could see all three of those here, the top being inspired by sgraffito, going all the way down. Andy created some beautiful samples for us that you could see in those circles. The idea was to kind of keep the roughness on the top surface while incorporating some color into the recesses. And so we started kind of playing with all of these ideas in-house by creating 3D printing these textures on rollers and using that to imprint the clay. And you could see here that whole process. And I think one thing that was important that we were looking at was the idea of creating 2 different scales of texture. So in this one specifically, you could see we first went through with a linear texture and then kind of overlaid that with that arrow shape. And so you get a different kind of compression, you get more variation in the surface. Here are some results of those tests. And then kind of scaling that up to a manufacturing or fabrication scale. Andy Brayman kind of showed us how this could be possible with an extruder. So kind of attaching the roller, which we sent to him, to the end of the extruder. So this kind of showed us that it was possible to do this at a larger scale. These are some examples of initial glazes with those textures, and you could kind of see the result of pooling and some of those qualities that we were trying to go for. And thinking about color, we wanted to do something kind of bright, something bold, and also it kind of keeps in line with the whale and sea theme. So we were looking at different blues and greens and yellows. These were some of the final samples that Andy sent over, and as you can see, we chose that top right image for the final stair. And so kind of moving into the mock-up itself, of course everyone was bound by the size or the bounding box, and we'll go through kind of our process of how we went about assembling. These are drawings that we produced to kind of get Boston Valley rolling on the production. You could see just a couple examples. Then fabrication itself, both of our pieces were slip cast. They could be extruded, so the tread we designed so that it could be extruded. In a larger application, it would use less cost. But for this exploration, we decided to go slip cast, so you could see one of the advantages of that for the tread was we were able to kind of wrap the front and the back of the tread with our texture. Here are the final kind of pieces that Boston Valley produced for us. And then our assembly process was relatively straightforward. We had this plywood sled on an incline as a temporary structure that all of our blocks were loaded onto, epoxied together. You could see us assembling that on the left-hand side. And then once all that cured, the tension was introduced, so that spinal cord was brought into play. Everything was put into compression, and I think we'll have a little bit of an example of how our stair actually functions. So you can see it's functional, it's safe to stand on, of course. In an actual application, we would have a handrail. But yeah, I think that's all we have for you. Thank you.